Hello, welcome to the 2.4 day 2. Today our objective is to find exact values of trigonometric functions. Now what exact values means is I don't want any decimals in your answer. So we're going to find, say, the cosine of 135 degrees. Now we can type this in our calculator and get some big long decimal. But I don't want to do that. I want to find an exact value that will give me the decimal, like square root of 2 over 2, or negative square root of 2 over 2, or root 3 over 2, something like that. And that's what we're going to learn today. Right. Now we have to look at rationalizing denominators. 5 over the square root of 7. To rationalize the denominator, what I want to do is write this fraction so that there's not a square root in the denominator. So what I'll do is I'll multiply by the square root of 7 over the square root of 7. Notice if you multiply by this, you're just multiplying 1, which doesn't actually change the value of this fraction. And when we do this, our numerator is going to be 5 times the square root of 7, and our denominator is going to be square root of 49, which the square root of 49 is 7. So here we have rationalized the denominator because there's no square root in the denominator. Try this one on your own, pause the video, and see how well you can do. Hopefully you're done. If I multiply by root 3 over root 3, now I'll have 6 root 3 over the square root of 9, which is 3. Now we can go a step further because 6 divided by 3 is 2. Now we can't divide the numbers inside the square root with the number outside. We can just divide the two numbers on the outside. All right. Now, hopefully you can do this on your own, so pause the video. Hopefully you are done. We multiplied by root 6 over root 6, and I have 4 root 6 over 6, which this will simplify to being 2 root 6 over 3. All right. Now we're going to look at special triangles. This is a 45, 45, 90 triangle. If I know these two sides, my hypotenuse is going to be times the square root of 2. This is something that you just have to memorize. It's very, very important. The rest of the lesson you will not be able to get through if you don't know this triangle. If you forget, remember you can always do 1 squared plus 1 squared is equal to c squared, or 1 plus 1 is equal to c squared, which is 2. So the square root of 2 is the hypotenuse. Now this is a 30, 60, 90. If we know that's 30, 90, this has to be 60. And if that's 2, that's 1, and this side is going to be the square root of 3. This is also something you need to memorize. The short side is always half of the hypotenuse, and the short side times the square root of 3 is the other leg. Again, if you forget this, and you know these two sides, you can do 1 squared plus b squared is equal to 2 squared, or 1 plus b is equal to 4. I need a squared on there. Subtract 1 on each side, and b squared is 3, or b will be the square root of 3. So if you forget this triangle, and you know the two sides at least, you can always find the third. You really need to memorize these triangles. I can't stress it enough. This is the 30, 60, 90, and this is the 45, 45, 90. All right, here are some examples. Can you draw this out on your, I want you to draw this out on your paper, pause the video, and see if you can fill in the other two sides. All right, hopefully you're done. The hypotenuse is twice the short side, which is 10, and this side is going to be root 3 times the short side, so this is going to be 5 times the square root of 3. Now this is a 45, 45, 90. It's, if these two are the sides are the same, we know that these angles will be 45 degrees. So if this side's 5, this side's 5, and the hypotenuse will be 5 times the square root of 2. Here is a 30, 60, 90. So pause the video, see if you can do it on your own. If the hypotenuse is 14, hopefully you found out that the short side is 7. Now I multiply the short side times the square root of 3 to find my third side. Now we're going to do something where like I told you in the beginning, what our objective for the day is. I want to find the exact value of the cosine of 45 degrees. Now, 45 degrees, if I draw out a little coordinate axis here, is right in the middle, between 0 and 90. If I draw a line straight down to the x-axis, and here's our 45 degrees, I can draw any 45, 45, 90 triangle I would like, and then find the cosine of 45 degrees. I could do 7, 7, 7 times the square root of 2, 10, 10, 10 times the square root of 2. Now, if we keep it here, 7, 7, 7 square root of 2, cosine is the adjacent side, so adjacent to 45 would be 7, over the hypotenuse, which is 7 root 2. Now we can simplify this. 7 over 7 is 1, so 1 over square root of 2. Now I'll rationalize it, so multiply root 2 over root 2. And this is going to be square root of 2. Root 2 times root 2 is root 4, which becomes 2. So the cosine of 45 degrees is the square root of 2 over 2. Now 7, 7, 7 root 2 is not the easiest triangle to do. There's two different triangles that people consider the easiest. One that I like is the 1, 1 square root of 2 triangle. Because if you know this triangle, then you can just see it's 1 over square root of 2, which you rationalize, and it saves you this step here. There's also another way we can do it if I have my hypotenuse being 1. If our hypotenuse is 1, then we have to divide by the square root of 2 to get these two sides. So it's 1 over root 2, 1 over root 2. Now, this 1 over root 2 over 1 is the cosine. So, so this right here, this x value is the cosine if we rationalize it. All right. So let's go on to the next one. Sine of 135. We have to figure out where 135 is. It's going to be between 90 and 180. And that's going to create a 45-degree angle with the x-axis. Now I'll draw a line connecting it to the x-axis. Now remember, you can draw any triangle. I'll draw the 1, 1 square root of 2. Now since this is moving to the left, we have to call that a negative 1. That's moving up, so that's a positive 1. So the sign is going to be opposite, which is 1, over the hypotenuse, which is the square root of 2. And that's the positive square root of 2. I just got a little crazy with my pen. And again, we rationalize it to get root 2 over 2. So this is the same answer as the previous problem. Believe me, they're not all the same answer. It would be much easier if they were. Let's do cosine of 240. All right, so now at 240 degrees, if I start here, we know that's 0, 90, 180, 270. So 240 would be about right here. So if I drew my right triangle, between 240 and 180 degrees, that's 60 degrees. So we have a 30, 60, 90 triangle. You can draw any 30, 60, 90 triangle. I like the 1, 2, root 3. And we have to check our negatives. This goes to the left, so that's negative. This goes down, so that's negative. So the cosine of 240 is going to be adjacent, which is negative 1, over hypotenuse, which is 2. So that's negative 1/2. Let's try tangent of 225. Pause the video, see if you can do this one on your own. 225, again 90, 180, 270, 225 is going to be right here. If I did the tangent, we know this is 45 degrees, so this will be 1, 1, root 2. If I check my negatives, that's going to be negative and negative. So we're going to do opposite, which is negative 1, over adjacent, which is also negative 1, and negative over negative will just be a positive 1. So the tangent of 225 is positive 1. All right, cosine of negative 60. If you can do it, pause the video and see how well you do. All right, negative 60 degrees, instead of going around this way 60 degrees, now we're going to go backwards, or clockwise 60 degrees. So I'll say it's somewhere about there. I'll plug in my 60 degrees. And now if I put my sides on the triangle, it's going to be 1, 2, root 3. And now let's check for negatives. This moves to the right, this moves down, so that's going to be negative root 3. But that's not going to affect with cosine, because cosine is adjacent over hypotenuse, so that's going to be 1 over 2. All right, sine of 330. Again, try this again by pausing the video. 330 degrees, 0, 90, 180, 270, 360. So back 30 degrees from that. And the opposite is going to be 1, 2, root 3. Now we'll check my negatives. That's positive, and that would go negative. So for my sine, I do opposite, which is negative 1, over hypotenuse, which is 2. All right, one more. Tangent of 315. 0, 90, 180, 270, 315. Now if I label my sides, 1 and 1, and root 2, where this side is negative 1. Now, because that's not a root 2. There's a root 2. All right. So now the opposite is negative 1 over the adjacent, which is 1. Negative 1 over 1 is negative 1. All right. Hopefully you can do these. Now let's do some of the newer values. Cotangent of 150. 0, 90, 180, we need to come back 30 degrees. So if I draw my sides, that's going to be 1, 2, root 3, and this way is going to be negative root 3. So cotangent, we know tangent is 1 over root 3, so cotangent is going to be negative root 3 over 1. So negative root 3 over 1, or just negative root 3 for an answer. We'll try one last one. Cosecant of 225. So 225, we have 90, 180, 270, 225 comes back here. And that would create a 45 degree angle. So we'd have 1, 1, root 2, where these two are negatives. Now cosecant matches up with sine. Sine would be negative 1 over root 2. But cosecant is the reciprocal of that, which is root 2 over negative 1. So if we divide that, it'll just be negative root 2. All right, hopefully that's enough to get you through the homework. Good luck. Now we should see the connection between trig exact values and the unit circle. Before we look at the unit circle more in depth, let's familiarize ourselves with the degrees around the circle. So of course, on this x-axis, we're going to start at 0 degrees. Halfway is going to be 45. And that means this one is going to be 30 and 60. Now, if we go on the other side, this will be 90. And since this is 30 degrees, another 30 degrees is going to be 120. Another 30 from that is going to be 150. And this is going to be 180. Now this is going to be the 45 less than 180, so this is going to be 135 degrees. Now down at the bottom, we're going to add another 30 to be 210, then 240, then 270. Hopefully people know 3/4 of the way around is 270. Now our 45 degree angle here is going to be 180 plus 45, or 225. Now if we continue this, if we add 30 again, this would be 300, 330, and then this would again be 360. And in between here, this would be 315 degrees. All right, now that we know our angles, let's break it down and let's just look at the 30, 60, 90 triangles. Now if I wanted to find the sine of 30 degrees is right here. Now if this is a unit circle, the hypotenuse is just going to be 1, because the length of the radius around the entire circle is always going to be 1. Now if this is 1, the short side is always going to be half. We can have 0.5, or we can say 1/2. And this side is going to be 1/2 times the square root of 3, which we can write root 3 over 2. Now, if I wanted to find the sine is going to be opposite over the hypotenuse. So that's just going to be 1/2 over 1, which is 1/2. Now if I want to find the sine of 150, that has the same reference angle of 30. So we're going to have the same situation where it's 30 root 3 over 2. But now this is going to be a negative root 3 over 2, and a hypotenuse of 1. So the sine of 30 again is going to be 1/2 over 1, which is 1/2. Now if we go to 210, this is again going to be 1/2. This is 30 degrees past 180. And now this is going to be a negative 1/2 over 1. And the sine of 330, that's all the way over here. Now that's also going to be negative 1/2 over 1. Remember this root 3 over 2 was for, this segment here. So now it's negative 1/2 over 1, which is again negative 1/2. Now if I look at the 60 degree triangles, that's this one, this one, this one, and this one. Now our opposite of the 60 is going to be the root 3 over 2, where this side is going to be 1/2 and 1. These are going to be negative 1/2, root 3 over 2, 1. These are going to be 1s, and now it's going to be negative root 3 over 2, negative root 3 over 2. So you see the sine of 60 is going to be root 3 over 2 over 1, which is just root 3 over 2. At 120, again, it's going to be root 3 over 2. And now these two negative ones, it's going to be negative root 3 over 2 and negative root 3 over 2. So notice what's in common with the sines of all of the angles with a 30 degree reference angle. All of the values the same, just the two down here are going to be negative. Same with the 60, 120, 240, and 300. All of these reference angles are 60 degrees. The numbers are all the same, just the quadrants 3 and 4 have negative values. Now let's look at cosine and the 45 degree angles. So if we have 45, 135, 225, and 315. So at 45 degrees, it's going to be 1, 1, 1 times the square root of 2. But this is the unit circle, so we're going to go from 1. Now to get these sides here, we do 1 divided by the square root of 2, which we can rationalize to get root 2 over root 2 over root 2 is root 4, or that's root 2 over 2. So these two sides are both going to be root 2 over 2. Now, that's going to be the situation for each of these triangles. Just we have to look at which ones are negative and which ones are positive. So over here, this is going to be a negative root 2 over 2 and a positive root 2 over 2, because here we move to the left, and right here we're moving up. But down here it's going to be a negative root 2 over 2, just like over here because we're moving down. All right, so the cosine of 45 is going to be the adjacent side now over the hypotenuse, which here is root 2 over 2. At 135 degrees, though, over here, the adjacent side is a negative root 2 over 2 over 1, which is a negative root 2 over 2. And 225, also using the same negative root 2 over 2. And over here, positive root 2 over 2. So cosine has a different pattern. Cosine is negative over here, but positive on the right-hand side, where sine is positive on top and negative on bottom. So let's see which signs each trig function takes. Well, just generally, we know that this is going to be a positive number. The radius is always going to be a positive number, or our hypotenuse. This is going to be positive. This is going to be negative because it goes down. This is going to go negative because it goes to the left. This is going up, so it's positive. This one's going down, so it's negative. Now let's think about sine, cosine, and tangent. In this quadrant, sine of theta is going to be opposite over hypotenuse, which is positive. Actually, all of them are going to be positive. Adjacent over hypotenuse, positive. And the tangent of theta is always going to be positive because positive over positive. Now if we move that to quadrant 2, now our sine of theta, I'm trying to think and write, never a good idea. All right, sine of theta is going to be opposite, which is positive over positive. So that's definitely going to be a positive answer. However, our cosine is going to be adjacent over hypotenuse, which is a negative answer. And our tangent is going to be opposite over adjacent, which is positive over negative, which is a negative answer. Now if we move that to this quadrant, we know that sine is opposite over hypotenuse, so negative over positive will be negative. Cosine is negative over positive, be negative. And tangent is a negative over a negative, which becomes a positive. Now in this last quadrant, quadrant 4, sine is going to be opposite over adjacent, so that's negative over positive. Cosine is now going to be a positive over positive, which is positive. And our tangent is going to be negative over positive, which is negative. So this will show us which sign each trig function will take on in each quadrant. There's a lot of ways people can remember that. Some people remember because all of them are positive here. Sine is just positive here. Tangent is positive here. And cosine is positive here. You can come up with your own term. Some people start in quadrant 1 and work around and say all scholars take calculus. I've had students in the past like that it says cast, and they're like casting over the unit circle. Thinking about fishing. Whatever you can think of that can help you remember that all just sine, tangent, and just cosine are positive. Go right ahead and use. All right, so now you can use the unit circle to solve some of these problems.